Your problem is that you don't understand your problem. That is what happens when you try to split monoliths into microservices. So today I'm going to talk about our journey from moving from A and B, two monoliths, to around 150 microservices. I am Geshan Manandhar. I call myself a senior software engineer, a tech solution provider, agile follower, and conditional microservices believer, because microservices does not fit all the teams. So your team actually has to be rightly structured so that you could do microservices well. I am originally from Kathmandu, Nepal, the only country that doesn't have a rectangular flag, as you could see. And currently, as far as I know, Nepal is pumping around $1 billion into the Australian economy with the students that's flowing in. So, and yes, it also has Mount Everest, the highest peak in the world. That's a lot about me and Nepal. Yep, so this story crosses continents, crosses oceans. This is about my previous employer, which is Namshi, one of the GFG companies. And this is an older story where we split two big monoliths into a lot of microservices. And currently, I work at The Iconic, which, as you can see, is in Australia, of course. Who of you know the brand The Iconic or have shopped from it? Okay, a lot of people, like almost more than half of the audience. So you know that this is Iconic is a fashion e-commerce company here in Australia, headquartered in Sydney, and we ship stuff to Australia as well as the New Zealand. Basically, we sell shoes, clothes, anything related to fashion. For many people, and also for many people at The Iconic, I actually came from a future which did not have legacy monoliths. Monoliths generally have three L characteristics: large, legacy itself, and lethal. So if you don't know how to navigate through monoliths well, they become pretty cumbersome when you want to work with them. What do I mean by that? So sometimes working with older, large legacy app feels like pushing a van like this, like two people are really trying to push it from the back, but it's not really going anywhere. So these are the types of problems that you face when you work with large monolithic apps that have been there for a long time. Many people put a lot of code in there, a lot of patch in there, a lot of things that shouldn't have been there. Some people made it overcomplicated and just made a mess out of it. It is very difficult to maintain, very difficult to make things work. So what should you be expecting out of this talk? In my opinion, nothing. Because this is a story, as I said, like how we moved from 2, 3 big monoliths into a lot of microservices, micro frontends, and everything. But as I said, like this is more of a story. You need to get the learnings out of it. You might find something that's interesting, but don't expect a lot out of this talk. Let's get started. So what is microservice architecture? A visionary in this field, Martin Fowler, I think a lot of you would know his name, basically says it's a single application as a suite of small services. It's built around business capabilities and can be deployed independently. Those are the highlights from what he thinks is a microservice. Another influential person in the microservice space, Chris Richardson, says they are loosely coupled services, and the technology stack could evolve. Both of them, if you see, focus on the same point, and that's business capabilities. So whenever you're thinking about breaking monoliths into microservices, always think about the business slice that's going to come out. Don't just think of the technical things that are related to breaking monoliths into microservices. So let's again cross oceans, cross continents, and go back to Namshi. Namshi was my previous employer. I've been here for almost a year now, and before that I was in the Middle East, Dubai, working with Namshi, same domain, fashion e-commerce, same parent company, but Namshi is not part of GFG anymore. So let's start the story. it all started, we had two big monoliths. One was the front end, and the other one was the back office system, the whole thing that actually ran the whole e-commerce website. As you can see, I would be giving a lot of examples of e-commerce and fashion e-commerce because I have worked with fashion e-commerce for more than 7 years now, so a lot of my examples would be geared towards that. Then we started breaking those two monoliths, mainly the back office system, and 5-6 years back in 2013, it wasn't really called microservice, it was called SOA, service-oriented architecture, and then we built a C out of it. So we had A and B, and then we built a C. But in 6-8 months, almost a year, we quickly realized that we built another monolith, and then that was another mistake. But as time passed, and in the past 4 to 5 years, we learned from that mistake, and we didn't extract out a monolith into another monolith. So we extracted out a lot of smaller actual microservices, and then as far as I know, in January or February this year, these two big monoliths that I'm talking about, that I'm referring to, are not there anymore. Everything is microservices there at Namshi, which is, I think, a very good thing that has happened. What helped us in that particular migration? One of the things that actually triggered a very good transformation for us was migrating to REST-based Geshan APIs. What do I mean by that? Before that, it was basically those two monoliths spitting HTML, JavaScript, and CSS all out, like it wasn't segregated into backend and frontend, and that was a mess to maintain and pretty difficult to change. As soon as we started moving into REST-based Geshan APIs, give me Geshan, I give you back Geshan, it helped us a lot. Because at that time, 4 or 5 years back, we didn't even have any mobile apps. It was just the desktop apps, and then it had a kind of a mobile theme, and that was working. But with this particular change, we were able to build mobile apps, and because the backend was just JSON, it could talk to anything, mobile app or even a CLI app if you wanted to make out of it. And that also helped in terms of testing because everything was an API, so even if I wanted to check out, I could just run a curl and then I could actually check out. So these kinds of things helped a lot. Basically, always try to model your microservice into smaller backend services, REST APIs, and that's going to help you. Another thing that actually helped us very well in this thing was having stateless auth. What do I mean by that? That basically means not saving sessions or anything on the server. Your servers are cattle, not pet. They can die anytime. So as soon as you have that mentality and you start doing things stateless, it makes it a lot easier. So there was no state kept. Everything was in a JWS token, JWT token. And then for ease, what we did was we started passing those tokens as a cookie because the browser automatically attaches it and then sends it back on each request. This also saved us from the hassle of adding another header or doing other things to it. So that made it very easy, and then authentication became pretty smooth. One other thing that comes to my mind is the authentication was not the responsibility of the application. We moved it one layer up to the web server itself where Nginx was basically handling it. And as soon as Nginx passed it to the application was sure that, okay, the person is authenticated. The application didn't have to add other logic or other code just to see that the person was authenticated. Yes, there were things related to roles and stuff, but just for pure authentication, nothing was there on the application level. A chunk of the backend applications are still in PHP, but now and even in the past years, everything has been built into Node, which has helped us a lot with the things that Node gives, the synchronous things as well as the event loop and everything. As if you can really use it well, it gives a lot of advantages. And then all the front ends are in JavaScript. We kind of bent towards using React, so most of the front ends are in React. So as I said, like currently, probably Namshi has more than 150 microservices now because it's been a year that I've left Namshi. But a thing to note there is all of it was done and made possible with just around 10 backend engineers. What you need to think out of here is it's difficult for bigger teams to move faster. So if you have a smaller team, I think it's lesser people to convince, lesser people to sell your idea to, and smaller teams move faster. Of course, we broke some rules, but I think we knew what rules we were breaking and what calculated risks we were taking, and we were paying that technical debt in time later. But having a smaller team actually helped us a lot. Let's say if we had a backend team of, I don't know, 50 engineers, I don't think the pace would have been that fast. So some of the microservices that we built in those 4 or 5 years, I recall some of them. For example, OMS basically means order management system. It's where the customer service agents come and then they see what's the status of the order. And if somebody calls, they can tell, okay, this order is placed, is shipped, or it's coming to you in X amount of time or X number of days. That was very helpful. Another thing that I remember is the Picket app that's basically in the warehouse here. It's called the fulfillment center, that someone goes to pick that particular item from the tote or the box, whatever it's called. That actually helped them a lot because that was part of an ERP, and that interface was clunky, so we moved it out to another microservice. Another microservice I worked with that I recall that actually increased their productivity by 20 to 25% was the Studio production app. That basically means something has landed to our warehouse and then it needs to go live. So all the steps between that of booking a model, taking the images, making sure that it's recorrected, retouched properly, and then it goes live. So all of these smaller microservices that are basically slices of the business actually help the business move a lot faster and deliver what the customers want a lot faster than with those 2 giant monoliths, which were very difficult to handle. Yeah, as I said, like moving into microservices enabled us to ship changes faster because things were broken, things were independent. One thing that again comes to my mind is that we split the domain itself for customer-facing app than the internal apps. Like the apps that the employees use had a different domain, and then the customer-facing app was in a different domain. So that actually made it very easy just looking at the domain that says, okay, this is a customer-facing app, and this is an internal employee-used app. So if it's an internal app, probably you could kind of sub-optimize it at places and you'd still be fine. But let's say if it's a customer-facing app, you had to really go all guns and try to make it fast, do all the optimizations. And if you think of it, how did it enable faster changes was, let's say if I change something on one of the internal apps, I never have to worry that it's going to break checkout. You know? So that was the freedom, that was the pace that was enabled with all this splitting. And same thing, let's say if you change the wish list even on the customer-facing app, it's not going to break checkout or something critical. So you can be very free and you can deploy that thing even at 2 a.m. in the morning and you are pretty sure that it's not going to touch anything critical. So this kind of segregation helped us a lot to ship the changes much, much faster. And yes, of course, this is Container Camp, so I should be talking about Kubernetes and Docker. Anyhow, Docker and Kubernetes really helped us stabilize the infrastructure. Before that, we had a lot of VMs, and like that was working, that was fine, but as soon as we introduced Kubernetes, actually Docker first, it was a lot easier. We started using Docker, I think, in 2014, 15, something like that, and 2016 itself, we had Kubernetes in production. Someone was telling me that it's a bit ahead of the curve, but in 2016, I remember we had Kubernetes in production. That helped us a lot for things like networking, all the artifacts that Kubernetes provides. That helped us a lot, basically. And to be honest, we never had DevOps or SRE team, whatever you want to call them, bigger than 3 people. So for those guys, I think it was a boon that we actually chose Kubernetes and used it. Yeah, another thing is, even now, 9 out of 10 applications are written in Node.js at Namche. Why am I focusing on Node.js? Because we were using PHP, and then it doesn't have the capabilities of asynchronous programming, that event loop, and trying to use the resources very well. So one example that comes to my mind is we actually rewrote one of the applications, and there should be a blog post in the Namche tech blog about it. It was 70% faster and with half of the resource. So these kinds of things actually triggered us because, one, we were not taking all the baggage of PHP as well as the bad code that was with it. But with Node, as it was a greenfield project, a fresh start, we could do whatever we want and however we want to optimize it, which made a very big difference in performance. Yeah, but with all of this, I've told a lot about the good parts of microservices, but microservices is not free lunch. It's not that silver bullet that's going to solve all of your problems. With microservices, sometimes it might mean that you're just scratching the tip of the iceberg, and a lot of things are there below it. So there comes a lot of configurations, a lot of networking things with microservices, because earlier you were just deploying A or B and just two things, and everything was connected from that inside the code. But now you are doing things like service A talks to service B, and then service B talks to service C. What if C is not inside your network? If it's A, B, and C, and all of them communicate with HTTPS, they have to do a SSL handshake on that, and how long is it going to take? So all of these things you really have to think about, and if A, B, and C are not in the same network or the same VPC, you are going to face a lot of issues. It's not like I have this thing, I pick it into 10 things, and they're just going to work automatically. It's not going to happen like that. You really need to architect your solution. You really need to plan how the network is going to look and how is it going to help your customers. So now let's look at how did we actually get started with microservices at Namche. Because as I said, it was like a 5-6 year long process. So where did we actually start? We started by looking at opportunity that we could extract out of a business function or a feature. Because I'm talking about e-commerce, fashion e-commerce. So one of the things that I remember we started doing was, so for an e-commerce website, whenever the order is placed, it just comes to your regular OLTP system, your regular thing, and then that order has to go to your ERP. That's where the thing is. That's where the stock is, where all the finances are done. So there needs to be a link that's basically called an order export generally. So we started doing things that were as small as this, that the order export could be extracted out into a completely new microservice rather than trying to change it into that big monolithic code base that was lying there. So things like these became our starting points, and those were the opportunities that we cashed in, and then we made it work. Another thing is try to transform a pain point into a new service. What do I mean by that? In terms of e-commerce, one of the pain points that we had with the monoliths that we were using was communicating with couriers. For instance, we were talking with 3 or 4 couriers depending, and then there was kind of a matrix or a formula that could take the right courier depending on cost and the customer experience and other things. And if we had to do it in the monolith, it would be a big pain and it would take a lot of time. So what we did is we extracted it out into a completely new microservice. We did all the formulas and everything, and then it was a lot easier. Another thing that we did with this new microservice is with couriers, as long as you get the AWB is an area bill number, that's your tracking code that you get. So as long as you can get the AWB attached to that shipment, you are done. It doesn't need to be synced. So we tried to push the process as async as possible because we were just creating shipments, leaving it, and then another process was actually trying to get the AWB and put it into that shipment. And if that takes 2 minutes, no one's dying. It's not checkout, it's not payment, So we tried to push as many things as possible async as long as they were not critical. And that really helped a lot. Yes, the other thing is communication and collaboration. and always roll out working software. Always try to start with smaller problems. If you go to the business and say, we want to rewrite the checkout, it's going to take 6 months, we want to do it. The first answer you're going to hear is no. 6 months, we can't give you that resource. But let's say if you go to the business and say, we want to do a microservice only for the wish list, it's going to take 1 or maximum 2 sprints. That equates to 1 month. Probably the first answer you might get is maybe, let's try it. So always get the business in the loop and always try to roll out working software so that the dev team gets the confidence of the business that, okay, we can actually do microservices. These 2 small things have already been done, and we can build upon it. So take this iterative approach and try to solve small issues. This is very important because many people come from apps which have hundreds of thousands or even millions of lines of code. This mentality of writing a microservice, they have to think out of the box. What do I mean by that? If people are used to writing 100,000 lines or a million-line code base, if they are used to maintaining that, they will want to pull in the baggage of, let's say, MVC, ORM, and all the patterns they know and everything, and try to put it into a microservice, which is never going to be larger than 5,000 lines of code. So if you are writing something that you foresee even in 6 months, 8 months, or a year to be less than 4,000 or 5,000 lines of code, don't bother using MVC, don't bother using ORM and then making it like all automated and everything. Just make it work, like make it as small as possible. Just go with raw SQL queries. They're faster. You don't need an ORM when your database hardly has like 5 tables. And you don't need all that mapping, all that baggage. So think of this. Yep, another thing when you start extracting monoliths into microservices that's going to help you and keep you on the safe side is be very careful of the deployments and the switch that you make. Always use feature flags and canary deployment. An example that comes into my mind is we once had to replace one of the payment providers. And as you know, for an e-commerce business, the one that processes your credit cards, that's the heart and soul of the business. That's where the money comes from. And we had to replace that, because we were working with Bank A, and they were not really providing what we needed, and we had to move to Bank B. So how did we go about this? What we did was we did all the development. We tested it pretty well, like as far as we could do it on staging. But the day we went live, we didn't open it up for 100% of our customers. What we did was we only opened it up to the people where the email address ended in yourcompany.com. So even if there was a bug, only the people who are inside the building would be affected, and then we could solve it. And even though you test everything, test all of you can on staging, there are going to be something that slip out and then that reach to production. So that was our first step of actually replacing a payment provider. That was step 1. Step 2, as we did that and we found some small bugs and we fixed it, the next week we turned it up for 2% of the customers. And then we still monitored, we checked that everything was fine, and that new microservice, new payment method was working, the new payment provider was working fine. Gradually, week by week, it became 5, 7, 10, and I think in a course of around 1.5, 2 months, it became 100%, and then Bank A payment provider was decommissioned, deprecated, whatever you want to say. The code was still there, but we cleaned it up later, and then 100% of our traffic was on Bank B, which provided the features that we needed out of a payment provider. So always think of this. Because you are making a new thing, that's a change. And if the business is not confident, always have it under feature flags, just release it to, 1% of the customer, look at it for a week or so, and then gradually increase it. This is where I think things like Kubernetes, probably Istio and all of it could also help from an infrastructure point of view and not only the code point of view. Some key takeaways. It requires a lot of inter-team communication. So what do I mean by that? Until unless the business does not buy into the idea of actually splitting the monoliths into microservice, it's not going to work. You as a developer or as a DevOps engineer, SRE, you could be ranting about moving into microservices for weeks, months, but it's not going to happen. It has to come top down. So the business actually has to buy into the idea, and then it requires a lot of communication to actually make it work. Replacing the front ends might be a task of some months, X months, but replacing the back office system is going to take years. So you have to plan for that. Even if you extract small things out of it, it is going to take a lot of time for the whole thing to be rewritten or to be restructured as microservices. So a simple pun here. Because microservices, you will start splitting into a lot of distributed systems. Matthias says there are only two hard problems in distributed systems: exactly once delivery and guaranteed order of misses. The pun is pretty clear. So basically, this comes out from a very famous quote that says there are only two hard problems in computer science: naming things and cached invalidation. Similar thing, the thing that you need to keep in mind here is systems you design need to be resilient. You have to question what happens if this fails, because not failing is not an option. It's going to fail. It's how fast can you recover from that failure. That's very important. So whenever you talk about distributed systems, they are bound to fail. They will fail. But the thing is, how fast is your recovery? If your recovery is slow, then you run into more problems. If you can recover fast, you're still fine. Yeah, this is something that I get asked at times. It says, so how small is a micro? What is a nanoservice? I don't know what a nanoservice is, but one of the smallest microservices I wrote was hardly 100 lines of code. And that was basically, if you check out and you put a new address on the checkout, it's going to be saved into the sales order part of it, but it's not going to show up on my addresses when you log in, so the customer address part. The simple code I wrote, which I think is a cron, runs every 5 or 10 minutes, is just copies those new addresses into the customer addresses, and whenever the customer logs into their account to their my address space, they see that new address being reflected there. So that was a very small microservice I wrote, and it was just around 100 lines of code. So yeah, microservices can be really small. Do you want to call it nanoservices? I don't know. That's just a play of words. So towards the end, it's always about the speed and agility of software delivery. If you're not delivering working software and you want to do microservice and you want to release every 3 months, that's not going to happen. So if you want to jump into the bandwagon of microservices, you always need to think of smaller problems, getting stuff done, getting the business buy into it, getting the confidence, and then delivering software following things like the ones that I said. That brings me to the end of the talk. If you have any questions are welcome. The Iconic is hiring. We are hiring a platforms engineer as far as I know, and other roles. You could just click that link. That's my Twitter handle and my blog.